We're supposed to solve which numbers again? Somebody say something?
I think it's 4, 8, 11, and 12.
4, 8, 11, 12. Are you sure? Not 3, 4?
And 3.
There's 3.
And also 3.
Okay. So there's 3, 4, 8, 11, 12, right? Okay.
Yes.
So, anyone been able to do 3? Let's start from there. Let me open my worksheet. Where is it? Where is it? Question bank, members functions. So question 3 says, find all linear functions which are self-inverse. So if you have done it, what did you get? Before I explain to the class.
Mr. Daniel, I did it, but I don't know if I...
You what?
I did the question, but I don't know if I did it right.
So what did you get? Just tell me the last function you got.
I got fx equals x plus a, where x is a negative integer, or negative.
X is negative?
Yeah.
I don't know what you mean by that, but x plus a will not be self-inverse because x is not meant to be restricted to negative. X could be any negative. Yeah, x is a variable. The argument can be from can be from specific domain. So for example, if you insist x is negative, so let's say we have minus 3 plus a. What about a? There's nothing been said about a. You get my point? I think you have some idea. You have probably just not put it right. Can we have more contribution? Thanks for that anyway, Ethan. Let's have another person give us an idea what they did.
Fx equals x.
F of x equals what?
X. And fx equals b minus x.
F of x equals what?
B minus x.
True. True. So what is b?
Any real number.
Exactly. What if I told you these two functions are just one function? Can we say that? Oh, the identity function is self-inverse. Yeah. Okay, I was going to say both can be combined if b is equal to 0, but if b is equal to 0, that would be negative x. So I think you're right. These two will be sufficient. Is someone confused how we got this? Is anyone confused? Does everybody know how it is x and b minus x? So if I ask you to work it out, you'll be able to work it out. I gave you an idea yesterday on the board. Do you remember? You let the function be ax plus b. Is that what you did, Lillian? Okay, all right. So I'm asking this and I need everyone to respond, please, so I know if we need to do it or not. So I need everyone to respond. Is anyone confused with these answers? The functions will be f of x equals x and function b minus x. If you are confused or you need to see a solution, please say something now.
I need to see the solution.
Okay, Leo. Karen, you look confused. Are you?
I also want to see the solution.
I knew it. You look confused, but you're not saying anything.
Okay.
How about you, Crystal? No, Kodebi. Okay. How about you, Crystal C? I just need you to, I just need you to tell me the true state of your, of your understanding. All right. So I need you to tell me. So let's look at the solution together. All right. Okay, let's go to the board. So today is 25th. Let's start with that. 25th. He's already 2 months at home. So nice. Okay, so correction from yesterday. The question is about, the question says, find all linear functions which are self-inverse. Find all linear functions which are self-inverse. So the solution will be to select the functions no, define f of x as a linear function. But because of this word linear, all linear function will be in this form. We mentioned that yesterday. Then we find the inverse. So let f of x be that. Then let y be f of x, like we always do. And if y is f of x, or should I say let f of x be y? If f of x is y, we know that x will be f inverse of y. You remember this? From f of x is y, it means f of x here is ax plus b is equal to y, which implies that ax equals y minus b, which implies that x equals y minus b divided by a. Sorry, I'm going to quickly log off my WhatsApp. Okay. So, and this x is actually f inverse of y. So we can conclude that f inverse of x is x minus b divided by a. Okay. So for this f to be f inverse, for f to be self-inverse, for f to be self-inverse, tell me the next thing I need to say. Do you understand my question?
Not. Yes, I think.
Okay. For f to be self-inverse, what is the condition? Any f to be self-inverse, what is the condition? No idea? Callista?
For f to be self-inverse.
Callista. Okay, what is a self-inverse function? Brandy, can you help?
The inverse is this,
Yeah, that's what I'm asking. So for f to be self-inverse, f of x will be equal to f inverse of x. That's what I'm asking. Miss Karen, does it make sense? All right, so for f to be self-inverse, this must hold, okay? And this implies that our ax plus b, which is our f, has to be the same as this. Actually, we can simplify this way. X over a minus b over a. Can you see that? So I can write this as this minus b over a. Okay? So what does this mean? Then we can compare both sides. If you compare both sides, this implies that if you compare this, okay, to compare that, what does that mean? It means ax must be equal to x over a, and b must be equal to negative b over a. Does this make sense? So there are we can see two things. Two things must happen. So let's see our conclusion, our deduction. What can we deduce? What can we bring out from these two things? So from the first one, that is from this, you can cross multiply, right? Agree? If you cross multiply, remember our a is never 0. For this to be a linear function, it's a condition from here. A is not 0. Because if a is equal to 0, then it's no longer a linear function. It's a constant, like a number. It's a constant function, actually. Call it a constant mapping. All right, so a must not be 0. So if a is not equal to 0, then it's possible for this division to be done. Because you can't divide by 0, right? Okay, please, I need some acknowledgement of understanding. When I ask questions especially, I need you to tell me if you understand or not, all right? You can just nod your head. I can see everybody on the video. So you need to show me you understand. All right, so from the first part, I can get a squared x equals x. And from the second part, I can get AB equals negative B. From here, I can compare the coefficients. Of course, I'm not dividing by x. I'm comparing the coefficients. If these two are the same, it means that a squared is 1. And from here, do we know anything about b? We don't. But for these two to be the same, it means that a is actually negative 1. No, we can't say that. Can't say that. I just thought of something. We can't say that. From here, it will mean that AB plus B equals 0. Can we see that? So from this, I can factorize. Can you see? So it means either B is equal to 0 or A plus 1 is equal to 0. So either B is equal to 0 or A equals negative 1. From here, A will be equal to square root of 1, which means A is plus or minus 1. Now, the plus or minus 1 is part of this as well. So we have options. Okay? We have options. Is either your A is plus or minus 1 or your B is equal to 0 as well. So there are options. So let's see. Therefore, f of x equals, these are the one with all cases. Okay? Your A can be 1 and B is equal to 0, or your A can be 1, but A cannot be negative 1 at the same time. Let's write it as a conclusion now. Therefore, A is equal to 1 and B is equal to 0. I'm looking at this. because this is and, right? This is and, this is and. So this happens and this happens. Can you see that, everybody? Please look at the board. This happened and this happened. So if A is equal to this and this happens, so let's try to see possibilities. A is 1 and B is equal to 0. A is 1 and A is negative 1 does not make sense. Understood? Aha, understood. Okay. So we can't say A is 1 and A is minus 1, no. But we can also look at A is negative 1 and B is equal to 0. You can't say A is negative 1 and B and A is equal to negative 1 again. It's the same thing. Am I making sense? Karen, confused?
A bit.
Okay. Please, can you say something before I ask if you're confused or not?
Okay.
Okay. Do you understand how I got it? Yeah?
Yes.
Between, are you asking a question?
Can you go over again why you can't just do
I didn't hear you at all. What's wrong with your internet? I can't hear you. Hello?
buddy?
No, I can't. Hello? Please get your connection right and join us again. So, does everybody get how we got this so far? Can I get some acknowledgement from everybody?
Yes.
How about Leo? So far, you understand up to this point, yeah?
Yes.
So I think the conclusion is the issue. So let me re-explain the conclusion. So we broke this into two, right? We said, actually, I could have deduced it from here. I could say that coefficient of x on this side is a, coefficient of x on this side is 1 over a. All right? So if we claim that these functions are the same, so basically this is what we are trying to say. Look at it this way. If I have g of x to be 2x plus 1, and I have h of x to be 2x plus 1, are these functions g and h the same? Please turn on your mic and say something. Are they the same?
Yes.
Good. Now, why do we say they are the same? They have the same coefficient of x and the constant are the same. If I decide to change this to minus 1, can we say g and h are the same functions?
No.
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 So for this function, so for a polynomial, perhaps f1, which has maybe some, I'll use this summation. Do we still remember this? For this polynomial, there's nothing here. Maybe n start from 1, 0 actually, up to some k. What I mean is, so C0 will be a coefficient 0, x to the power 0 is 1. C1 is a coefficient of x to the power 1. C2 is the quadratic coefficient. Does this make sense? And it continues. For this polynomial to be the same as a polynomial, say g of x, where your n is also from 0 up to k, and it is dn x to the power n. So this means your first one will be d naught, then you have d1x, you have d2x squared, and so on. This is another one. Can everybody get this so far? If we claim that these are the same, for these two to be equal, what happens? C naught must be D naught. Do you agree? C1 must be D1. Does that make sense? And so on. Cj must be equal to Dj. For some j, your j could be 0, 1, 2, 3, we don't know. Am I making sense? So that's the point we're trying to make here. We're trying to say that if we must say these two are equal, then we can equate their coefficient. So I'm going to start that step again. Instead of going through this, so let's take the process again. Okay. So I just speak directly in terms of coefficient. So I use black for the coefficient of x and leave the rest as green. For the coefficient of x here, this is x over a actually. Okay. So if these two functions are equal, this implies this. This implies that a is the coefficient here, and 1 over a is the coefficient here. Does this make sense? Leo?
Yes.
Okay, good. So if you cross multiply, it means a squared is equal to 1. And that's where I got this, and that's where I got plus or minus 1. But there are two parts to this. The other part is that, and I use another color for that. These two must also be the same. What does that mean? B must be equal to negative b over a. Okay? So which means that AB is actually negative b. Mind you, we are solving both of them simultaneously, so we can actually make use of these values. Okay? So when a is 1, you're going to be having b equals, so look at it this way. If a is 1, let's just quickly check. You have b equals negative b. The only possibility is b must be 0. All right, everybody? When a is minus 1 also from here, when a is minus 1, I'm going to be having minus b is equal to minus b. That solution, there's no solution here. Do you understand this point now? So in any case, the other option is b is equal to 0. Okay? So it's either b is equal to 0 or there's no solution here, which means b could be anything. Look at it. Minus b is equal to b. If b is 1, yes? Does it work? If b is 2, does it work? If b is 500, does it work?
Yeah.
So the one with no solution, maybe I shouldn't say no solution. I should say infinitely many solutions, since we have a good knowledge of properties of some of this linear system now. Am I making sense, please?
Yes.
So let's see. So I'm going to substitute. I think this is a better way to explain it than my previous approach. Perhaps okay, I think I'll write it in a better way. Sorry. So from here, this implies that a squared equals 1. This implies that a is square root of 1. And this implies that a is plus or minus 1. Let's put it that way. Okay. From the other side also, b equals negative b over a, which implies that ab equals negative b. So let's substitute what we know. When a is equal to 1, it implies that b equals negative b. b equals negative b can only work when b equals 0. Do we agree? Because if you put 1, you can't say 1 equals negative 1. If you put 7, you can't say 7 equals negative 7. So this implies that b plus b equals 0. If I bring this to the other side. Okay. And from this, it implies that 2b equals to 0, then b equals 0. Because we can divide both sides by 2. when now there are two values for A. When A equals -1, it implies what? Negative B equals B, negative B. If negative B equals negative B, it implies B is equal to B, which means B can take any value. Okay, then B can take any value. All right, let's see. And this is why Lillian got the friend. So this implies B is any real number. Okay, B is any real number, including 0, of course. So you could see the options. We can have A is 1 and B is equal to 0. You can have A is -1 and B is anything. So for the first one, so conclusion now. A equals 1, B equals 0 gives our function. A is 1, B equals to 0. So let's see from here. Can you see that? Okay, our function f of x, that's ax plus b from the beginning. That's our assumption. Then this function will now be what? A is 1, B is equal to 0 will be x. Agreed? Agreed? Erin, lost? Because from the beginning, it says a linear function. We started with a general form of linear function, and now we have solved to see different possibilities. When A is 1, B is equal to 0. So we substitute to get what is the real function now. Okay? Then also, A equals -1 and B is any number in R implies that f of x, which should be ax plus b, is simply -x plus b, and that is b minus x. Agreed? Okay? A is -1, B is any number. So if it's any number, just leave it as B. All right? Aha. So the conclusion is that f of x, which could be x or b minus x, okay? All f of x, which is this, are self-inverse. That's the conclusion now. All functions like that are self-inverse. So there are two possibilities, like Lillian rightly got. There are two possibilities. So please take note of this solution. If your solution is slightly different and you wish to check if it is right or if it can be presented that way, please send it to me on WeChat. Then I can let you know if that is allowed, if the steps are in order, or if you have sufficient workings to be shown or not. Okay? Can we move on? Does anybody still need any minute to write something, or is everybody okay? Okay, all right, so let's move to the next one. The next one is, under what condition is the rational function y equals ax plus b equals divided by that is self-inverse? Has anyone tried it? Talk to me, 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 talk to me.
Can you ask again? One question?
Question 4, Mr. Cheng, as everybody
Yeah,
said.
I tried that.
Hoodie man, hoodie man, hoodie man. All right, so how about you, Lillian? She's going to get another food. Need to get, that's okay. Quickly go get whatever you need to get. Verna, did you try 4?
No, I haven't.
Speak up, please.
No.
Oh, okay. Clarissa, you try 4? Okay. Nakita?
Kind of, but like it's kind of half because I'm kind of stuck. Yeah.
Okay. I just want to know if there are attempts made, all right? It doesn't have to be perfect. So how about we do it together again? Karen, how about you? Did you try 4? Made some attempts?
Yes, but I don't know how.
Okay. Let's see. Mr. B, what up?
I tried a little bit, but
Not sure.
absolutely not get nothing.
Okay, can anybody tell me, just based on the ones we have done now, what would be the first thing that you need to do to attempt question 4?
We need to find the inverse function first.
And when we find the inverse, can someone else tell us what the next step would be?
Compare.
Compare. Before you compare, you have to do something before you can compare whatever you need to compare.
Cross multiply.
What are you cross multiplying?
I don't know
Before you cross multiply.
Okay.
Okay.
I don't know.
Because they are both going to be in rational form. So it's right. We need to cross multiply at some point. And maybe that's where all the complexity of whatever comes from. So let's see. Krista K, you all right? You haven't said a word since and you look confused. Confused.com. Confused.com. Is that the correct website? Confused.com?
I tried, but I don't know if it's correct.
I just want to know if you are okay and if you're following what I'm saying.
Yeah, I'm full.
All right. Okay. Okay, let's go back to the board and try this together. Hoodie man, hoodie man, hoodie man. Hello, hoodie man. Okay, so the question says, under what condition is the rational function self-inverse? So the rational function is y equals ax plus b divided by cx plus d. And there are some conditions. C is not 0. Meaning we need the denominator to also be a linear function, not just a number. Okay, so we find the inverse of this. So let y be f of x, then we find the inverse. So this is f of x, so let's, I could even use g this time, so we're not just using f. Let y be g of x, then g inverse of y will be x, okay? So in that case, what do I say now? It's already in form of y anyway, so let's just make it a subject. Okay, so from here, we can cross multiply, and that will be y brackets cx plus d and ax plus b. So that gives cxy dy ax plus b. We need all the x together. So cxy minus ax. Okay, but I move to the next line. So cxy minus ax and b minus dy. So we factorize cy minus a, b minus dy. So x will be b minus dy divided by cy minus a, or it could be dy minus b divided by a minus cy. And this is actually g inverse, not f inverse, g inverse of y. So which means g inverse of x is either we say b minus dx divided by cx minus a, or we say it is dx minus b divided by a minus cx. Is this what we got? Good. So for G to be self-inverse, Ms. K, give me the equation. For G to be self-inverse, it implies that what?
That G of x equals G of negative x. No, G of negative 1 x.
G inverse, just call it G inverse. All right.
G inverse.
Like that. Okay, good. So we could use either of this, it doesn't matter. Can you signify, for those that have done it, if you got the first one I wrote? How about the second format? Anyone got the second format instead? Okay, so we use the first format. I just wanted uniformity. So we make use of this then. We use that format. So what does this mean? It means that g of x is ax plus b divided by cx plus d will be equal to b minus dx divided by cx minus a. So we want to see under which condition would they be equal. Basically, what can you say about A, B, C, D? That's what under what condition means. Okay, that's what under what condition means. So let's see. I don't know what it will look like, but we can find out together. So let's do what Brandy said. It says we cross multiply. Yes, we're going to cross multiply. If we cross multiply, we have ax plus b, we have cx minus a, then on the other side we have cx plus d, and we have b minus dx. So we expand and compare coefficients, basically. So if we expand, I have acx squared, trying to write clearly, but my hand isn't balanced on this screen. acx squared, then I have minus a squared x, then I have plus bcx minus ab. On the other side, we have cbx. Now, we arrange it in alphabetical order so we can see clearly. On the other side, we have bcx, then we have negative cdx squared, right? Then we have bd, then we have negative d squared x. Any error? Please check if I've made any mistake. So, one approach is to compare on the other side, but before I do that, I'm going to arrange it in order. So AC, the x squared term first, then the x term. So the x term is this. So I bring x out like that. Then in the bracket, I'm going to be having negative a squared plus bc, then minus ab. On the other side, the x squared term is this. The x term are this and this. So I'm going to say x bracket bc minus d squared. And the constant term standing alone will be bd. Please tell me if you understand what I've written so far or not. Understood? Okay, good. What?
Why did you have to expand though? Can't you just compare from g of x equals g minus 1 of x?
We can't do that because if their denominator was the same, then we can say that.
Because
you mean to say maybe d is equal to negative a?
Yeah.
But also, does that mean, okay, I'm looking at what it's saying. It has a point, you know, because even at the denominator, a will be equal to negative d, and b still remain b, c remains c. It has a point there. It has a point there. You have a point there, actually. My fear is if you compare two functions, x minus 1, this will have to be x minus 1. For certain values, the function may not, it says for all values, right? But they may not look alike, but it doesn't mean when you substitute x, they won't give you the same results. That's the reason I'm trying to do this expansion. But you have a point. If we are to compare directly, then we could say that for these two functions to be exactly the same, denominator will be equal and numerator will be equal. Is right. Maybe we just go straight with that. And we can actually see that from here. You can see that from here also. Here. Can you see? In fact, in every term is there. Okay. I was just afraid of unnecessary generalization, but clearly we can see it from here. So if you look at the first term, we can get it. So from here, AC. So if anyone concludes from here, I welcome that. I will give you, if this was an exam. So from here, A is equal to negative D. If I compare the middle term, this, or negative A squared plus BC equals BC minus D squared. So definitely it means if you subtract, this can be subtracted from both sides. Negative A squared equals negative D squared, which means A squared equals D squared. So this is where I might have problem. If A squared equals D squared, what happens? Then A is plus or minus D. Can you see that? Okay, let's see which, now A is minus D works. What about A equals D? If A equals D, it doesn't work because you can see that from here. Can you see that? So from here, only A equals negative D works. So I'm picking the correct one because the other one is not accurate. Or better still, we can say A equals that, and also D also equals plus or minus A. Agree? Because both of them are squared. Talk to me, everybody. So in any case, the only possible option is A equals negative D. And if you look at the third term from here, or negative AB equals BD, what does that mean? It means that if you divide both sides by B, okay, well, not that you can divide by B because your B could be 0. So what really happens is we actually just do minus AB minus BD equals 0. That's better. Then you can factorize and say, let's see, what can we say from here? B is factorizable, yes. Then we have negative A, or we can pick minus outside the brackets. Then in the brackets, we have A plus D equals 0. How about I write that somewhere else? Not here. Let's manage some space. Let's write this one. Either this happens or D is plus or minus A. So there are two options here. Either A is equal to D or A is equal to minus D. We leave that, then we pick, of course, this is already one of them, so let's leave that as the way it is. Okay, the last option from here. Actually, the connection between them shouldn't be or, it should be and, because all of them must happen simultaneously. And the last option will be negative AB. Now, can someone tell me why? I'm going to ask a question now. Here, I'm saying we cannot divide both sides by B. Hello, class? In the first one, I divided by C, but here I'm claiming we can't divide by C. Can someone tell me why I'm saying two things that are different? Here.
It says question C is not 0.
Question C is not 0? What do you mean?
It says in the question C is not 0.
Okay, so that's why we can divide both sides, because if you divide by C, it means you are dividing by non-zero, which makes sense. But here, it never said B is not 0, because B could have been 0. Your rational function could be AX, CX plus D. That's the point we're trying to make. Okay, so that's why we can divide somewhere and we can't divide somewhere. So where we cannot divide, we try to solve it as an equation. So which means you bring it together. Negative AB, negative BD equals 0, which means negative B is common, A plus D in the brackets. So if we have this product, it means either negative B is equal to 0 or A plus D is equal to 0. And finally, either B is equal to 0 or A is negative D again. It's negative D again. So there are options that we have. So Ethan, can you see something now? Mr. Chang?
Yeah.
If we pick from here directly, we are only going to restrict it to A equals negative D, right? But there are other possibilities. So like I said, you are not wrong. I wasn't just so comfortable with picking it. And we can see clearly that that assumption was right. We need to actually go deeper because there might be other options that we have. Okay, so let's see how we can summarize this. If A is minus D, A cannot be D at the same time. Do you understand? So if A is, so class, are you listening? Because I can't see everybody's faces now. I'm trying to look at the entire board. So I need you to respond. So we have this and this. Sorry, just a sec. My charger. Not the deal. I'll show you the balance transfer. Okay. What's it show? Can I okay. 1 minute, please. Is it charging? All right. Okay. So it's not charging. Quickly. Okay, I'm good. Okay, so everybody look. So there are three options. So we can either have, let me find a neutral color. Okay. We can either have this condition, and this condition, and this condition. That's what it means. This condition, and this condition, and this condition. So some conditions that are not related will be discarded. So it means that we have A is minus D, and A equals minus D, or A equals D. Do you agree? Those are the two conditions from the middle one. Sorry. So from the middle one, either A is equal to minus D or A is equal to D. And from the last option, either B is equal to 0 or A is equal to minus D. So if we pick the first condition here, we cannot pick anything here. Does everybody agree with that? Because your first condition, please, I need you to say something. Unmute your mic, please. I can't see everybody's faces. So when you nod, I can't see you. Okay? When you nod, I can't see you. So I need everybody to unmute their mic. And I'm trying to use the entire board, so I do not want the video covering the board. So I've off my own view of you. So again, if we pick from here, A is equal to negative D, do you agree we cannot pick anything here?
Yes.
Yes.
Because if we pick this, is a repetition. If we pick this, what happens?
It doesn't work.
Why? Use the word, something we have learned this year.
Contradiction.
Thank you, Brandy. So again, you pick the first one, you try to pick this, is a repetition. You try to pick this, is a contradiction. So you go to the third option. In the third option, the only thing available for you is this. So it's either A is minus D and B is equal to 0. Can you see that? So for A is equal to minus D, you can always only pick B is equal to 0. So you come to the middle now. If A is equal to D, let's see. Can you have this? Yes. Can you have this? No. Do you understand? So either when A is equal to D or when A is minus D, B can be taken as 0. Let's see. If A is equal to minus D, and do we have anything for B to be alone? Yes, we can actually have that as well. So I'll say conclusion for me will be A is equal to minus D and B is equal to 0. If A is equal to D, A cannot be minus D again, so we can say B is equal to 0. What happens when B is just B? Any suggestion? I'm trying to deduce something for that. Come on, come on, come on. When B is equal to B, when B doesn't change, what happens? Is A still equals minus D or is A still equals D?
When B is just B, A equals negative D.
When B is equal to B, but A is equal
A
to?
equals negative D.
Okay, can you explain that to us?
What?
Can you explain that to us?
Why it's like that? I just substituted minus D for A and left B alone, and it worked.
You substitute. Okay. So,
yeah.
So there are two options here, basically. Is that what you're saying? When A is equal to B, you are saying our B could be 0 or B could be any number.
Yeah.
Okay. Does everybody get what he's trying to say? Hello?
Yes.
Yes.
Okay, so let's see, because if you look at it from here, actually, we only have one value. Nothing is said here about B. Nothing is said here about B as well. So let's pick the third one. When A is equal to negative D, our B could just be any real number. What about when A is equal to D? Can B just be any real number? No, it's only for when it is negative B. So the options are 3 according to this. So the 3 options we have is the first one, y equals, when A is negative D, so we're going to have AX and B is equal to 0. That's for the first one, all right? So y equals, for the first option here, I have x, b is 0, so I'm not considering that. Nothing is said about c, and d is just negative a. So this will be cx minus a. The second option will be a is equal to d, but b is equal to 0. So I have ax divided by cx plus a. The third option will be when b is any number. So I have ax plus b divided by cx minus a. And b could be positive or negative. This is exactly the previous one of the exercise we did last time. That's the format. Look at the board, everybody. Look at this PDF document. Can you see this? In this case, you could see that your A is equal to negative D whenever your B stands. Can you see that? But then your C is equal to 1 is an option here. Is there something we are missing where C is meant to have been 1? Guys? Is there something we are missing? Hello? Come on.
I think it still works.
What?
I think it should still work.
When C is 1?
No, when C is anything like when C is more than 1, it should also still work.
It also still work. Okay, so then C can be a general number. Okay, C is a general number. So we've got these three possibilities. So I'm going to check to see what they have for us in that.
Mr. Daniel,
Yes, please.
I'm not sure about the A equals D and B equals 0 one though.
Oh, really?
Yeah, because I substituted it in. I don't know. Maybe I did something wrong. Can I send out a WeChat?
Okay, send it. Let's see.
Right.
Let's see functions. I'm trying to see something now. Where is it? Rational functions, inverse functions. Okay.
You see it?
Okay, I'm coming. I'm trying to find
I
the
just basically substituted in A for D and I put B as 0.
Okay, give me a sec, please. I haven't checked that. Hold on. Find all rational functions. Where did I get that question from anyway? I'm looking for the question, the original from question. Okay, so it's from question 20 of one of the exercises. Question 20 of exercise 15F. So let's see what happens. Yeah, exercise 15F, question 20. Okay, question 20 should be close to, let's say 725. Almost there, 727. Okay, one more. So the options are D is equal to negative A. That's all. What? Does it mean there are no self-inverse function when B is equal to 0? Yeah, this is what I'm saying. Looks like we have done even more than what we're supposed to do. I don't want to believe this is the only one. Check. Look at this.
Because B is because B can be any real number, right?
Oh,
yeah.
So 0 is included. Is that why that was skipped? Is that what you're saying?
I think so.
Yeah, I agree now. Because if we say B is a general real number in general, 0 is part of it. So there's no need to separate that, basically. Does that make sense, everyone? Hello. This is what we're talking
Yeah.
about. So I come to the board. Here, for this b is equal to 0, it's included here. Okay, it's included here. Mr. B, understood? All right, so let's just follow the simplicity they have here. So the cross multiplier, you see, Mr. Cheng, the comparison was not from here. Can you see that?
Yep.
All right, so there's need to do this, what we did, and bring these terms together. Okay, then just take the coefficient from here. Okay, and d is equal to negative a is the only thing we need. Of course, as long as AD is not BC, I think that's another condition. Product of AD must not be the product of BC. Why is that important? From here. Okay, does that make sense? Okay, so I'm going to write it in the simple, So let's fix it in a simple, not too complex way. From here, we're good. As long as this, so the condition we should say here is that this must not be equal, because if these two are equal, then we have what? No quadratic, right? Talk to me. Hello?
Can you say that again?
This must not be 0, and this must not be 0, basically.
Yeah.
Okay, so the technique they have used here is different from what I did. So let me explain what has been done here. If you're trying to compare AX plus B with CX plus D, what I have done is to say compare the coefficients. A is equal to C and B is equal to D, all right? What they have done is to bring everything together and say AX minus CX, then plus B minus D is equal to 0. Because for F to be equal to G, it implies that F minus G is equal to 0. Does that make sense?
Yes. Yeah.
You need to talk, please. So
Yeah.
so using this, we can bring this together, right? And what that means is that A minus C bracket X plus B minus D is equal to 0. So if this function is 0, it means A minus C is equal to 0 and B minus D is equal to 0. Agreed? Because that's like 0x plus 0. So it's still comparison somehow. So from here, A is equal to C, and from here, B is equal to D, which is exactly what this is about. Does that make sense? So that is the technique that was used from this point. Okay, so I'm going to write this step and use that technique to explain better, then we can change our summary. But basically, it's the same thing, actually. I'm just trying to deduce this square part, okay? We're still going to get this anyway. Either way, we're still going to get this. Let's see. For the square part, we're saying this must not be 0 and this must not be 0, basically. AC must not be 0 and CD also must not be 0, because if they are 0, it means what happens is no longer, we don't need it to be quadratic. What am I saying? We don't need it to be quadratic, so we are good. Yeah, okay. AC is not equal to that, so let's see. All right. Permission to take this part. Actually, I should write on the next page. Next page. I was thinking of not rubbing everything, that you can have different things that I've written to go through later. We should have even stopped by now. Okay, so from this point here, I just want to explain the way that was done, all right? So we haven't really, not that what we did is not acceptable. From this point, let's collect all this together, the square term, then this term, then this term. Let's see. Actually, there's no need. There's no need. I think I'm just confusing myself. There's no need. Guys, do you understand what I'm trying to explain here?
Yep.
If you do not speak, I can't hear you because I minimize all the windows for the video. I'm trying to use the entire board. If I open the video, it covers part of the board. So please, you need to talk, not just do this. I can't see you do that, please. So does everybody get what I'm trying to explain here?
Yes.
Yeah.
Yeah.
So maybe there's no need to redo this because I was going to bring all the terms together and show it that way. So what we just have to do is just to compare the coefficients. If we compare the coefficients, then we can get this only. Okay, we do not need all this A is equal to D kind of stuff because if you look at it, A can't be D even from here. If A is equal to D, it means when the function has positive here, has negative here, we are claiming they are the same, and that's not supposed to be. If A is equal to D, then we are saying AX plus B divided by CX plus A. That doesn't look right. So that doesn't look right. So I will just stick to this. Okay, we'll stick to that, and I'll take this off. So there'll be no need. We just compare one coefficient. Let's make it simpler. Okay, coefficient of x squared will do the justice. Let's make it simpler. Then on AD equals BC, let's see what that looks like. Where's our AD? Our AD is where? That's here. Hello. AD equals BC is one of the, is not equal to BC is one of the conditions. Is it BC? Let's see. One of the conditions, AD must not be equal to BC. Let's see what that means from here. If AD is not equal to, where do we get BC again? This is BC. Where's our AD? We don't have it. So where does that come from? Hello?
Maybe after you put it all on one side.
Ask what?
Maybe after they put it all on one side.
On one side. Now, okay, I'll show you that again. So you see what I'm talking about. I didn't know this would take this long. Can you see it? Can everybody see this?
Yeah.
Okay, so if you look at that, so here, enough, we can always get, we get this. When you divide by C, yeah, then this is self-inverse. If D is equal to negative A, then AD is not equal to BC. That's what I'm trying to say. AD is not equal to BC. Where does that come from? Oh, here. From here. I don't know, why do they have to go through this? Oh, can you guys see? The asymptote. Hello?
Yeah.
So if you do that, why do we need to do this? Using that asymptote technique that we did before. So B minus that must be 0. If that is 0, then we have, which is not invertible. Yes. For it to be invertible, this must not be 0. That's it. They're trying to tell us when the function is not invertible. That's another, that's the first condition that was taken care of. Can you see that? If this is 0, okay, then this function is left with A over C, and this is not invertible. Like if you have 1 over 2, what's that? Okay, if you have 3/4, okay, so it's not, we can't say it's just a constant function. Do you understand what I mean?
Yes.
Hello? Hello?
Yeah.
It's just a constant function. So it means for the inverse to exist, this condition, this part must not be 0. And that's where this comes from. Then we can move on to what we did. Okay? So I'm going to send this to you, then you can have a comprehensive solution. Is that okay with everyone? So instead of us doing it again on the board. Does that make sense?
Yes.
So I skipped that first condition. And I didn't think of that. Sorry about that. So, but for this, it's enough to just do this and stop, basically. So we don't need all this necessary stuff. And we don't need to put it back. It never says find all the functions. The instruction was find the condition, okay? That's instruction, find the condition. So again, this is the second part of the solution. This is not the first part. So this is the second part. So the first part I will send to you, okay, to be sent. So please write it properly in your notebook in case I ask you in some exam or something. Understood, everyone?
Yes.
Okay.
Yes.
So due to the time, are there any other issues from the ones you solved?
So
Class, talk to me, please, quickly.
No.
Okay,
No.
so this looks like the major one. How about question, I had finally, question, what is that question again? That has to do with inverse. Inverse is a condition given. What question is that? You're given F inverse of something. Question 8. Is there a problem with question 8?
No.
no.
Okay. Can I get a response from Krista as well?
No.
Okay, you're not talking, that's why. Okay, so this is the major one, so please. So what I would do is, after I send you the solution for the other parts, I'll come up with a new question, maybe not in terms of A, B, C, D this time, so you can try it on your own. I will require that to be submitted. Is that okay?
Okay.
Yes.
To be submitted. So you practice these errors, because as you can see, I also made some blunder doing this. So you can practice that and get used to what I'm trying to correct. Okay, is that okay, everyone? All right, so that will be a submission that I will require. I wouldn't waste much time on these worksheets anymore. Please take some time to do practice on your own. Maybe later, hopefully when the school resumes, or maybe I can dedicate a class to some other practice, because I don't want us to still do this on Friday. But if the class thinks we should spend another time on these worksheets, then maybe we could do that on Friday. What do you guys think? Should we just go to something else that I need to do and leave you to practice, explore the remaining part of the worksheet on your own? Or do we dedicate Friday's class to practice and, monitoring ourselves like this online, learning from mistakes? Or I could just leave the rest of the worksheets for you to deal with and move on. Come on, what do you think?
I think maybe like just find some questions that you think will help us in practice, and just like let us, and then just like give those numbers to us for our own personal practice. And then we just move on to the next topic. And if we have questions, we just ask you.
What do you guys think about that?
Yeah, that's okay.
No problem.
That's okay? All right. So I'm going to select some questions from the worksheet. One thing I've noticed, which everybody will agree with me, is that if it does not require submission, some people don't do it. Some people don't practice. So I'm going to make it look like a practice work to be submitted, and maybe it's okay if some things are not clear, because Ethan was still talking to me about some question from last worksheet. And you will notice I never said, oh, deadline, you should have submitted, blah, blah, blah. It's okay if some things are not clear. So, but the ones that you are able to do, of course, you do it. But the idea that, oh, Mr. Daniel needs me to submit this will force you to do this practice, even if you want to be lazy. Do you get my point? So that's the main reason why this I will be assigning this to you. Okay. So I'll pick some questions, like you said, and I will expect your solution maybe by weekend, so we can spread it over, not just 24-hour submission. So let's say Sunday. Will Sunday be good for everybody? So I can put Sunday afternoon or evening. Brandy, don't wait till Sunday morning. I don't trust him. All right. So we extend it to Sunday, and if anybody needs extra time, usually for your class, I do not lock the homework even after deadline. You can submit, but it would be nice so that when someone comes to the class and say, "Oh, I don't understand question 5," and someone is yet to even attempt it, then it's not fair to discuss the solution when there is no attempt from someone. Do you understand? So this is why you should. And when you're doing it, you might even get more educated yourself, okay? Finally, before we leave, you will notice I uploaded something 2 days ago, I think, or yesterday, and I deleted it immediately. Apologies. And Nakita had actually submitted. By the time I deleted, I'm like, oh my God, that was an error. We discussed on Monday, if you remember, that I planned an investigation on quadratic function, the behavior, and some other stuff, right? And before I came to discuss that with you, I had prepared that investigation. I'd already uploaded it on Edmodo, and I already scheduled it to be live on your wall by Tuesday afternoon. So after we spoke about it, that was maybe Saturday or even Friday. So after we spoke about it on Monday and we agreed that the investigation will be postponed, pending the time that we will say goodbye to this worksheet, which we just did now, then that thing should have come live, say, tomorrow afternoon. Unfortunately, I forgot to reschedule it on Edmodo. I slept off. I was doing some other stuff, and I just decided to go online to maybe post the link because the school now says 24 hours before the class, we need to post the link. And I saw one submission. I'm like, wait, what? What is this? So immediately I pull it down. Luckily, she saves our copy, so she doesn't have to start all over again. So that I will be uploading that tonight. It won't be due until, say, 1 hour before the class on Friday. It's not something difficult, okay? It's just to prepare our mind towards the quadratic function to be discussed on Friday, okay? It's always good when you see the behavior of something before we now get into the class. That's when you understand it much better. Does that make sense, everyone? Okay. Tomorrow I'm a bit free. Friday I'm going to work, so I'll be teaching you from SON. Woo! Yes, we can go to school now, but it's going to be weird, I know, just teaching people that are not here. But let's see how it goes. Should be fun. Then you can tell me to show me how your class looks like. I can take the camera around and show you your class. So your chairs can say hi to you as well. Anyway. What?
Wait, why do you have to go to school?
Because we realize that we still need more collaboration among ourselves to be able to support you guys better. So we're going to be coming, not every day, so some selected days, and we'll be talking about how we can do more for you guys and what are the things that people need. Say, for example, from one English class, I think they're done with some reading. The other text is in school. There's a new term, even though everybody is home. So the school needs to think of how do we get this to the students so they're not lacking too much and things like that. Some of your books are in school. So the school might tell you, if you get in touch with Mr. Long, that, oh, my textbook are in school, this is taking longer, what do we do? Then he might tell you, okay, maybe send somebody. Students are not allowed to come. Maybe your parent can be allowed to come and pick some stuff for you. Who knows? If anybody needs their book, let me know. Then I can ask them. Then they can tell me if we need to bring all your book. I know where the books are, the textbooks I mean. we have it in our shelf in the classroom, isn't it? Right? Your textbooks? Is that where they all are? Aha.
Yeah.
So maybe
No, I think some people have them in lockers.
their lockers. Then maybe the school can arrange some helper to come, some parent to come, one after the other. I don't know if anybody needs their book, because this is probably going to take longer than expected. So we're still all stuck in the house. Okay, so these are some of the reasons why as staff, we also need to come together and deliberate on some of this stuff to be able to help you better. Okay? All right. So see you guys on Friday. Get enough sleep. I need to sleep. I'm not really doing the way I should have done today. I think I need to sleep. I'll see you on Friday. All right?
Okay.
Stay safe.
Bye.
Bye.
Bye.